Greetings, everyone. Welcome to my YouTube channel. Ladies and gentlemen, tonight I want to take you through part 4 for Introduction to Python Programming. Already, I have created a video on part 1, and also we went through part 2, where we spoke about the operations. And also part 3, we spoke about the operation on strings and also the issue of loops, where we went through the while loops and the for loops. Right, now in part 4, ladies and gentlemen, I want to take you through something called the list comprehension. And after the list comprehension, we'll talk about what is called the Numpy and Pandas, ladies and gentlemen. Right, we need to understand what we mean by a list comprehension. Already, you know what we mean by a list. I think if you remember this, a list, it's another type of a data structure, which we have covered in part 1, like the dictionary, like the tuples. But now, ladies and gentlemen, I want us to talk about what is called a list comprehension. Right. A list comprehension is just a way of computing or a way of making iterations like what we have done in the conditions of for loops. But this one is just a simpler way of making iteration, maybe like in a one code rather than creating a very long code. Let me just give an example based on what we have covered already. Let's now go back to the issue of the for loop, like what we have created earlier. Remember, we said within this code, we said with this loop, in terms of the for loops, we created a code whereby we wanted to display the squared numbers. For example, if we have the following function, like what we have done earlier, we said when Tn is equals to n squared, where n is greater or equals to 1, then we want to print out the square of this number. For example, if n equals to 1, then 1 squared will give us 1. And if n equals to 2, then it will become 2 squared, which is 4. Then n equals to 3 squared, this gives us 9. Up until, just an example, when n equals to 9, which means 9 squared gives us 81. So we have already created what is called a for loop. We created a for loop in the previous video to say we need to print these values 1, 4, 9, 81, but in the form of a list. But by so doing, I want to explain what we have done already. From this, we just created an empty list. This is an empty list in Python using the for loop. So now to do this, I'll say, okay, fine. We created an empty list. And within this empty list, we want to say, okay, for every value of n that is in a range from 1 up until 10. What does this mean? It means that if we do a ranging, for example, if we do the range of numbers from 1 up until 10, we want to say for every value of n, I apologize, for every value of n, if n is 1, n is 2, n is 3, and so on, we need to substitute this value of n into the function. So this code, it says for n in the range from 1 up until 10. We know that when we use the function range with a start of 1 and a stop of 10, but we know it means this will increment this value from 1, 2, 3, 4, up until 10 minus 1. which is actually 9. So that's why we use this. So it means we want to actually say for every value of n in this range of 1 up until 9, we want to calculate the value whereby this value, we want to substitute this value of n inside this, and we make it to the power. Remember in Python, we spoke about if you do this, this represents an exponential or a power. So this n asterisk 2 is the same as n squared. So this is what we have. So what it will do, it will take any value of n inside this range and substitute it inside the n. And now from here, after calculating that n, it has to append every value of n inside that empty list. So it means when for example, inside the empty list, when n equals to 1, then it will substitute where there is n by 1 and gives, then take this value and append it inside the list. So it will be 1. And again, when n equals to 2, it will do the same and append it will be 4, just so on and up until the last value. So by so doing, then it means this is a for loop. We have actually created a for loop to present this output. So now we're gonna do this. We'll say, okay, fine. To do this, let's run this code. Obviously, it will say the np dot a range is not okay. It's fine. You see, it has now printed the values that we are looking for: the 1, the 4, and the 8. Even if we can use, I think, even if we can use the range, if we can say for n in a range between 1 and 10. I think it will still give us the same value. It will still give us the same value. So now this is what we have done when we use the for loop. But now we introduce a new concept called a list comprehension. Right? A list comprehension is just a way of making iteration like what we've done in the for loop, but without having to show a lot of code. By just using one simple code, then we'll still present the same thing. This is called a list comprehension. All right, let me talk about this list comprehension in terms of how it works. So we have something called a list comprehension, but it's not about having a list comprehension. We can still have something called dictionary comprehension. We can have something called a set comprehension. We can have something called a generator comprehension, but which will still work exactly as what is called a list comprehension. Let me explain its syntax on how to actually use this list comprehension. Right, when we are using a list comprehension, it means in our code we need to have what is called a list. Remember, we said in Python, a list, it's represented by the closed brackets or the square brackets. Once we see a square bracket, we know this is called a list. So it means now what we're going to do, we're going to create iterations, or we're going to create a code inside this list which will work exactly as the for loop. So which means that we're going to say, right, within this is the syntax for a list compression. So it means inside a list compression, we always have a list. And again, this is what we're going to have. Number one, we'll have something called an expression. An expression is just an equation that we want to use. Then again, we're going to say for value in id. So once you say for value in, this is an example of a for loop. We're actually using a for loop inside this. So it means for value in iterable if condition. So sometimes we need to put this condition, but the condition is for now, it's optional. It's not a must that we must keep on putting the condition. It depends with what we are actually looking for. So what does this mean? It means if we were to compare this for loop here, we can now change it to be a list comprehension. But how are we going to change it? Let me try to explain this. If you look at this value equals to the actual, if we say Tn equals to n squared, this is actually the expression, is what we're actually looking for. We want to get this expression. This is the expression based on the values that we were looking for. So which means that within this expression, you must say the expression for value in the iterable if condition hold. So let's do the same. Let's now do the printing. I wanted to actually print the same result that we used when you use a for loop, but this time around I want to use something called the list. Okay, I apologize, guys. I had connection issues. As I was saying, that we can create what is called the list comprehension, which will work the same as that one of the for loop. But now to do this, we're gonna say, okay, fine, we're gonna do this. We are putting everything inside a list. So what do we do? I'm gonna say, fine, I want this, I want the expression. Remember, I said this is the expression. It is the expression that we want. This is the expression. So the expression will say, we want n squared, n to the power of 2. So it means we are telling this to say, make the n to the power of 2 for, remember I said if within this there is a condition for what? For any value of n which is inside the range. So I'm going to copy this. So this is what we want actually. So we'll copy this and paste it there. Then we're going to paste it there. So then inside there should be this. So I wanted to explain to you so that you can understand. Because here there is no any condition that we must follow. It means if I were to look at this, we're going to say, okay, fine. This expression here, the n to the power of 2, this is the expression. So it means this is actually the expression. This is the expression. Then within the expression, remember we said the expression for, then we have for the value, our value is n in an iterable. Iterable means here, look, we are using the range from 1 up until 10. So this is an example of an iterable because it will iterate values from 1, 2, 3, 4, 5, 6, 7, 8, 9, which is the last value. So it will say for any value of n that is inside this item. So it means it will say when n is 1, then it will perform this. When n is 2, just like that. Since there is no condition here, then we will run this. You will see that it will still give us the same result as when we use the for loop. Look what you're going to get. Let's run this. So it will say, you see, it says the n to the power of 2 for any value of n inside the range of 1 up to 9. You see that this is just a shorter way that perform the same result as when we use the what? A for loop, as when we used a for loop. Remember here, we do not put any condition because there was no condition which was needed there. But how about if we wanted to do this? Let's say we wanted to say from numbers that are starting from 1 up until 30, we only want to get the even numbers. We only want to get the even numbers. So imagine if we do not want to use a for loop. If we do not want to use a for loop, it means we can use something called a list compression, which it's just going to give us one single code, which will just give us the answer. Let's say we want to get the following. I want us to, just an example. Let's say we want to use numbers from 1 up until 30. And within 1 up until 30, we only want to get the even numbers. The even numbers. And guys, what do we mean by even numbers? Look, even numbers, we are referring to 2, 4, 6, 8, 10, 12. It means these are numbers that are divisible by 2. Numbers that are divisible by 2, it means are those numbers whereby 2 goes into them and the remainder becomes 0 and the remainder becomes 0. So look at this. We know that if you wanted to check numbers that are divisible by 2 when the remainder is 0, we can use something called modulus. We can use something called the modulus under what we call the arithmetic operators. So if we wanted to only to display those numbers that are divisible by 2, where the remainder is 0, we can do this. For example, if I say, let's say I wanted to create a code, it's just an example. Let's say I'm going to say it's 2 mod 2. Okay, let me just say it's 12 mod 2 equals to 0. So what I'm trying to say, I'm telling the Python to say, remember when we say 12 mod 2, what does this mean? It means we want Python to display a remainder. I think I spoke about this in the first video, part 1. So if we say 12 modulus 2, it will tell us that this is a remainder of 0, 1. Okay, guys, I apologize. Just had connection issues. So as I was talking, as I was saying that when we use the modular sign, this will only tell us the remainder. So we wanted to check whether if it's 12 divisible by 2. Yes, 12 is divisible by 2 because the remainder is 0. But if you say it's 12 divisible by 5, 12 is not divisible by 5 because it gives a remainder of 2. So it's not divisible. So here, if we say 12, it's 12 divisible by 2, then we have a comparison operator. Then it will tell us that this is true. Yes, 12 is divisible by 2 because it gives a remainder of 0. So it says, is the remainder equals to 0? It says, yes, the remainder is equals to 0. But if we put 5 here, it will say false. Why false? Because 12 into 5, it goes, but it leaves a remainder. Because of that, it means its remainder is not 0. That's why it's saying false. So it means when we are talking about the even numbers, if you wanted to display the even numbers, we are referring to those numbers that are divisible by 2, which means if they're divisible by 2, it means they will give a remainder of 0. They will give a remainder. But we wanted to check from numbers that are ranging from 1 up until, but it will be up until 31. Why up until 31? I want the values to show from 1 up until 30. So that's why I'm putting 31. So now, which means if I wanted to show the even numbers, I'll say I want the even numbers. I want to create a list of even numbers. So by so doing, we're still gonna use a list comprehension. So a list comprehension, comprehension for even numbers. So we wanted to show the even numbers that are from 1 up until 30. We wanted to display the even numbers only. So it means to do that, you're gonna do a list comprehension. So I'll just say, okay, fine. I can copy this, but now I would just want to display the n, or let me just use k. I'll just say you only display the k. I want the k because it's not a function. The expression is we want the value of k for k in a range for k in a range from 1 up until 31. Why 31? It's because I want to show values that are from 1 up until 30. If I put 30, then the last number will be 29. But here, there should be a condition, because if I just say, look, if I just say k for k in a range of this, it will print all the numbers from 1 up until what? 1 up until 30. Let me show you. Let's run this code. You see, it's just printing all the numbers from 1 up until 30. But you see, within this 1 up until 30, we only want the even numbers, which means this time around, there must be a condition. Must be a condition. And what will be that condition? It means you must say, if what? If that value of k, the value of k, when it is divisible by 2, the remainder should be equals to 0. You see, it's a condition to say we want to only display or create a list of all the values of k that are within a range from 1 up until 30, but only show those ones that are divisible by 2. Remember, when we say divisible by 2, it means we want them to give a remainder of 0. So this is the code that we have shown. This is a condition. So you can easily see that from this list comprehension, there is an expression. The expression is k. The expression is k there. And within the expression, since the expression is the k, then we have a for k in. This is an example of an iterable. It's what we want to, like the iterable. Then this is the condition. We want to show the condition to say we only want to display the values of k from the list, from the iterable from 1 up until 30, but only show that those values that are divisible by what? By 2, which means if they're divisible by 2, it means the remainder would be 0. So let's run this. Let's run this. You see, it shows all the numbers that are divisible by what? They are divisible by 2. They're divisible by 2. Then how about if we do not want to show those that, let's try to put not here and check. If we say not, then if we say not here, not, let's do the running and check. It says there's a syntax here. There's a syntax, okay? So which means we're supposed to put, let's put double equals to and check. Oh, it's triple of them. Let me put another one. Oh, what is going on here? Okay, let's try to run this. You see, it's only showing the odd numbers. You see, now it's showing the odd numbers instead of showing the even number. It's because of the condition. It's because of the condition. So we have indicated the condition. For example, let's say I wanted to say, yes, we know, for example, if from this function, I wanted to print this, but I want them to print from value that is beyond, like from 4 and above. So which means there should be a condition to say, okay, fine, I can still say this. I can say now, okay, let me copy this function, this list comprehension, this one, we can do that. So we can say maybe if, let's say if the what, the n is greater than or equals to 2 or equals to 2. So you see, I'm giving a condition to say, please do the calculation, but consider where n is bigger than 2. So it means if we run this, it will start from 4 and above, which can still be the same as we say, it's fine. If we do not want to put this condition, we can say start from 2 instead of starting from 1. Let's do the running. It will still give the same output. So these are the things that you need to know about the list comprehension, which means in terms of the list comprehension, it gives the output. It actually, its syntax is just a one simple code rather than using a for loop. But it's very, very important to be able to know how to use a list comprehension. Okay, let's now continue with the next subtopic, which is Numpy and Pandas. All right, under Numpy and Pandas, you need to be able to know what is a Numpy and what is Pandas, and how to actually import this Numpy and Pandas library, how to import Numpy and Pandas library, and Pandas library in Python, and again how to use them. 4.2.3, how to use them or when to use them, how and when to use them, how and when to use them, how to use them. Okay, fine. All right, let's now start with the Numpy. Right, first of all, we need to understand what is called Numpy. Ladies and gentlemen, Numpy is one of the most important library in Python. You need to be able to use Numpy, right? The Numpy, in short, it's called the numerical Python. It's called a numerical Python library. So this numerical Python library, as the word says, the Numpy, it's used in Python to actually create arrays. We usually use it in creating an arrays object. And also it's used in linear algebra. In linear algebra, which is the video, like I will create a video we're talking about linear algebra, where we are creating what is called the matrices and vectors. And also this Numpy, it's used also when we want to get the mathematical functions, mathematical and also statistical function, but particularly the mathematical functions. Functions like, for example, in Python, when you want to calculate, let's say, the maximum value, what you want to know, what is the maximum value, what is the minimum value, what is the sign of a function, what is the cause of a function, how to calculate the tan, which these are just ratios, how to calculate the square root, maybe we are given square root, you know, a lot of things. For example, how to deal with an exponential. So this okay, guys, I apologize. I'm experiencing connection issues, but it's fine. As I was saying, as I was talking about the Numpy, that Numpy it's used in creating arrays. We can use it like in linear algebra when we are dealing with matrices, determining the dot product. We'll talk about that, and again we use it in like calling the mathematical functions, like what I was talking about. So now the question is, how can we import this Numpy? Right, before we talk about the Numpy, let's now talk about the library called Pandas. Let's talk about the library called Pandas. Pandas is another type of a library in Python, which is actually used in data manipulation, data reading, where we want to read data reading and manipulation. when we want to manipulate data or when we want to read data, we actually use these pandas. Usually, let's say we have a data, we're given a data that is in a data frame. Actually, when we say something's a data frame, it means it is in a table format. Let's say we have something like this. Let's say we have the data which is in a table format. Maybe it's showing the gender. Is this an example? The customer ID, those kind of things. You find that it has all the relevant information. So if you want to read this, it might be a CSV file or an Excel sheet, Excel document, or it depends with whatever or the SQL, or it depends with whatever the data. So we use these pandas to actually read the data. It's not about reading the data, but we can also do the manipulation. For example, we can create a data frame. We can create a data frame by using pandas. So these are the things that you need to be able, particularly when you talk about pandas and NumPy, are very important in Python. Then yes, when we want to read the data using NumPy, when we're using pandas, I apologize. So we are like, when you want to read data or manipulate data, we usually use pandas. So this is one of the most important libraries in Python. So the question is, how can we import these pandas and NumPy? I think in the previous video, I have used one example, but however, like I even said, I will explain this. Yet an example of the library that I have important. So this is the NumPy. So it means if we want to import the pandas and NumPy, we use the function import. Import, it means this is used to import libraries so that the Jupyter notebook or whatever the platform you're using, it can be able to use those libraries. So we're going to call it NumPy. So we're going to call it the NumPy. So to do that means we're going to say NumPy. So we're importing NumPy, but I'm going to put the alias, which is called S. So this is an alias to say, to avoid me keeping on using the full weight of NumPy, I'll just use NP. So it means I'm importing the NumPy, but I'm setting as it to be NP. And also I can import pandas as PD. So it means always should be in small caps. It means if you just, let's say you use a capital P, then it will not be able to read that. So you need to be able to know how to import. So this is how we import the libraries. So import the libraries. And now, ladies and gentlemen, I want to also import a library called statistics. Let's say we import statistics. I wanted to import these statistics. Then within these statistics, I think we'll talk about this. There is a reason why I wanted us to talk about this. So it means there are some libraries that are for us to use them, we need to use the function statistics. So let's do the importing here. So I'm importing all the libraries. Then if it does not show any error, which means it's showing that all the libraries are correctly imported. So right now, ladies and gentlemen, I explained what is a NumPy and how to actually use this NumPy. I'm surprised why it's taking time. Right, then now within this, the pandas, the NumPy, I'll just give one example. Let's say, for example, we have an angle, or we want to calculate, let's say, the exponential, let's say, e to the exponent of x, or maybe want to calculate the log of x, or we want to calculate the sine of x, or cos of x, or the tan of x, or maybe wanted to know the square root of x. It depends with what we want to like the square root of x. You know, those things we can use something called Numpy. Numpy can be used to recall this. So if I say, usually with Numpy, so let's say I wanted to compute, let's say I know the x, let's say it's 10, then I wanted to calculate the e to the exponent of 10. Obvious, e to the exponent of 10, this will be, I will say np dot exp. Once I say exp, already Python knows that I'm talking about an exponential. So if we run this, it will give us the answer. You see, e to the exponent of 10, it's that number. But I've said e to the exponent of 0, it will give me 1. Okay, actually, let me just put x here. So e to the exponent of x, that will be 1. So it depends with what we want to use. For example, if I wanted to use the log computation of a logarithm, computation of a logarithmic function. So if you want to use a logarithmic function, so I'll just say the np dot log. If I say log, the log of the x, it will give me the answer. Say the log of x. Okay, so it says here it is the infinity division by 0. It's not allowed. Oh no, it's fine because we used 0. Yes, it's fine. Let's just say 10. I apologize because the log it says none divided by 0 encountered. Okay, let's run this again. It means I did not run it. Okay, you see now it's giving us the answer. It's now giving us the answer. Then now about if I want to use the sign of x. So I'll say np dot sign of the x, then it will give me the answer. But already since we like I've imported the numpy, even if I can say, let's try to check this. Even if I say sign x, sign of x, let's check something. If I say sign of x and check, it says, or sign is not defined, which means I must say np dot sign of x, then it will give me the answer. Now about if I wanted to use the square root, so it's going to be np dot square root of x, then it will be that. You see, square root of x, for example, square root of 4, obviously square root of 4 should give us 2. Square root of 4 should give us the 2. So, no, square root of 4, not square root of 2. Square root of 4 will give us 2. So you see that we can use this. Numpy actually is used in like to call the mathematical functions. So for example, if we wanted to come up with the factorial, I think, yeah, in the context of factorial, so I can say np dot factorial of, let's say, factorial of 4, and then I think that will give us an answer. Okay, it says there is no numpy, has no module called factorial. I think it has to be, maybe it's me who would not. Okay, let me check how to call this, or is it the math? I think we need to import math. Okay, fine. It's okay. I think it might be math. Let me just say import math, because this is to do with mathematical. So let's say math factorial. So yes, it means we need to use the math because it says numpy does not recognize factorial. So we know factorial, we know in the lower grade, like in grade 12, we used to calculate factorial under counting principle, that we say n factorial, it's n times n minus 1, n minus 2, and so up until 1. So it means if we have 4 factorial, this will be 4 by 3 by 2 by 1, and 4 by 3 is 12, by 2 is 24. That's why it's giving us this. So you see that we can use it like like to calculate to calculate the factorials, to calculate the square roots, signs, all the functions. We can actually use this. And again, it's not about this only, guys. The NumPy can also be used in when we want to create an array. Let's say we have a list. Let's say we're just given a list. It's just an example. Let's say we have a list of values. Let's say the values it's okay, let me just say k for k in a range. I just want to display this rather than in a range between 1 and 10. Then I just want to create a list. Then after creating this list, let's print it. So it's either I say value, I want to print the list. You see, it has printed the values from 1 up until then. Now, what if I wanted to change this? Remember, if I say the type of these values, what would be the type of the values? If I say the type of the values, then this now it will tell me, or this is now a list. But I can still convert this list. I can change the list. Let's change the list to a NumPy array, to just become a NumPy array. So it means to do that, I'll just say values equals to np.array. So it means now I'm changing that list to no longer be a list, but to be a NumPy. That's why we say type. If we say value, let's do away with, let's print the value. If we print the value to show that this is an array, it's now an array. It's showing an array now. And if I say what type of this, if I say the type, it will show that now it's no longer a list. It's a NumPy ND array, the n-dimensional array. So this is a NumPy array. Actually, these NumPy arrays, we usually use them when we are performing what you call the linear algebra under matrices. But we can still use the NumPy array in reading data like what we have done. So this is just the functions. The NumPy array, it's actually used to I'm saying the NumPy is actually used in to get the mathematical functions. But there's some functions which we cannot get it direct from the NumPy, like the factorial, we get it straight from the math. And I strongly believe that even on maths, we can still get the square roots, sign, and even other functions. Then again, let's move on to the case of Pandas. Let's move on to the case of Pandas, ladies and gentlemen. Remember, we said Pandas can be used to read data. For example, if I want to read data which is in the form of a CSV file, then we'll say pd.read. Then I have to specify that this is a CSV file, and I'll put the file inside. If you watch my video for there's one video where I was talking about doing data analysis for customer chain. I've used this function, which you'll see it again when we're given a specific data, then we are reading. I can even give an example. Let's say from the data that I have already created, let's just get one CSV file and do the analysis, just to show you how to actually read. If it's an Excel, that means here we're going to put Excel instead of CSV. So remember, underscore CSV file. Okay, it's taking time. It's okay. Let's just leave it. Then again, we can also use something called, it depends with what we want to create. For example, if we have, let's say we're having, let's call the data. Let's say we're having a list of numbers. So I'll just create a list of numbers. Let's say we have 2, 4, 6, 8, 10, 12, 14. Yeah, it's just a list. Then another one, Y. Let's call this Y. Maybe let me say 1, 2, 3, 4, 5, 6, 7, 8. Let's hope they're the same. So it's 1, 2, 3, 4, 5, 6, 7. So it's 2, 4, 6, 7. 2, 4, 6, 7. So the 8 here, 2, 4, 6, 7. So let me remove 1. So let's say I wanted to create, let's run this. Remember, these are just lists. Let's say I wanted to concatenate this, or I wanted to form something like a table. So I will have to use something called pd.data frame. If you can Google online, you'll be able to see this. So once I do this, I can say I want the X. So I'll just say I'm creating a data frame of X and Y. So let's do this. Let's say we run this just to do an example. You see, we have created a data frame for those values. So 1 and 2, 2 and 4, 3 and 4. You see, we have created a table for this. So this is some of the functions that you can use when you are using Pandas, ladies and gentlemen. I think I will also create another video where we actually using this. For example, let's say I wanted to say, okay, fine. We still use this, but this time around, let me say the data equals to pd dot data frame, okay, frame of X and Y. Let's say I wanted to make the columns to be a list of X and Y. Okay, not the list of X and Y. Okay, I want to check something here. The X and Y. Then now let's do the running and check if it's giving us or it's giving us an error. Okay. It shows an error. It says shape passes value 7 and 1, indices is 7 by 2. Okay, it's fine, which means now we have to do this. It means I do not have to do this. And by the way, guys, you can get these things from like if you can just Google online, then you still see this. So if you come here and say, let's say pd.data frame, let's say data frame, just the data frame in Python, then it will tell you how the data frame is constructed in Python. So everything's just here, then you can be able to use it, ladies and gentlemen. Okay, let's come down. You see it's pd.merge, we can merge, or it depends with, okay, fine. I think this one is not giving us more information. Okay, let's just go back. You see, okay, that's fine, because already I have closed it. So it means it's a 2D, like when we say data frame, we're actually representing an n-dimensional. You see, like we can also use a list. If we say pd.data frame, we can even use a list to print, like we see here is the calories and the duration. Then you see this now a data frame. So you can easily see that this is one of the most, like how powerful it is to use a Pandas. Pandas is very important when you are doing data manipulation. So I think I will also talk about this in the next video. Right, then now, after this, we have an example here. Here it's an example. It says the number of liters of diesel purchased by 15 truck drivers at a gas station. Okay, apologies. at a gas station were recorded as follows. So this is the information we have. We are told that the number of liters of diesel which are purchased by 15 trucks drivers at a gas station were recorded. So we have 88, 2, 64, 55, and so these are the numbers. Then now the first question says calculate the mean of the number of liters purchased. So number one, we want to calculate the mean of the liters purchased. So number one, so we need to create a code to calculate the mean of the number of liters purchased. And ladies and gentlemen, to do that, we're gonna use Numpy. We'll use the Numpy to calculate the mean. But before we start using Numpy, ladies and gentlemen, let's now sort these values. Let's say we have our numbers here. Here it's the numbers. Let's now create a list of those numbers. Let's now create a list. You see how important our list. Let's create a list of the number of liters purchased. Now we are creating a list of the number of liters. So I'm going to copy these values as they are, then now, and put them inside this list. However, ladies and gentlemen, you can easily see that these numbers are not arranged from smallest to highest. Obvious, when you are calculating the mean, there's no need to arrange them from smallest to highest. But when you are calculating things like the median, the quartiles, then you need to be able to determine, to arrange numbers from smallest to highest. But with this, let's do the calculation. Obviously, I'm going to say mean equals to, remember, what is the formula for calculating the mean? We're calculating the mean by using what is called the X bar, which is the sum of all observation divided by n. So if we were to show maybe all the workings, we'll say, first of all, I mean, if I wanted to show all the working, I would say, let's get the summing. Let's say what will be the answer here when we sum. So let's say sum of the numbers. Sum of the numbers. What will be the sum of the numbers? So if we sum this, or it says numbers is not defined. Okay, okay, you see these numbers are, it's 1,104. So if we have 1,104 divided by the length of the numbers, if you wanted to show all, remember the length of the numbers, it's telling us how many numbers are here. So it means the mean here would be 73.6. But what if we do not want to show this? Let's say we do not want to show this long step of calculating the mean. Remember, let's say we don't want to show this. So let's say print the mean. If we do not want to show this, remember, if we do not want to show this, obvious, Numpy can still assist us to do that. Okay, we can still be able to use the function from Numpy to calculate the mean. And how do we calculate the mean using Numpy? Straightforward. It will just say numpy.mean, mean of the data. What is our data? The numbers. So we just say mean, and numpy.mean of the numbers. It will tell us that, you see, the mean is 73.6. So we have now calculated the mean using Numpy. So we have calculated the mean, calculating the mean using the Numpy library. So using the Numpy, we can calculate the mean. Then the second question says, write down the mode of the data. We need to write down the mode of the data. So we need to determine the mode of the data. Obvious, what do we do? When we are calculating the mode, remember, a mode is the number that occurs most frequently in a data set. And when you look at this data set, the number that is repeating itself most frequently, here it's 80. is 88, if I'm not mistaken. But to do that, it means we have to use something called stats, because this is part of statistics. So if you can recall the stats that I have imported there, so I'll just say, if I say, let's say, as an example, I say statistics, because I've imported statistics there, and I'm gonna call this function and say statistics statistics dot mode of the numbers. The mode of the numbers. You see, it says the mode is 88. But still, I can still do this and say, if I don't want to just use the long part, I can say, let's set this, let's say, instead of using import statistics, I can say, let's import these stats, but let's use a shorter symbol. Like, for example, if you don't want to keep on using statistics, so we can say, we can use an alias to say, let's set it to be as st, so sts, or yes, st, which means wherever we see st, we know it is statistics. It is my choice. So it means if I don't want to put statistics, I can just put st, because this is an alias to say I have set the statistics to be st. Then let's calculate the mode. So the mode of the data now is 88. So now the second one, it says write down the range of the data. Now we want to answer the next question. We want to write down the range of the data. By the way, how do we determine the range of the data? Obvious, we determine the range of the data by taking the maximum value minus the minimum value, or the highest minus the lowest. So this is the range. So which means now we can do this. We can say, to calculate the range, range value, this will be the maximum minus the minimum value. So maximum, I can say max minus the mean. But how do we determine this max? Obviously, we're going to use numpy. If I do this, if I say numpy dot max, within that, if I say max, then it will tell me what is the highest value in the list. So if I say max, you see it says the highest value is 98. But if I say mean, then it will tell me that the lowest value is 41. So to do this, I can say the max is the numpy dot max value of the numbers, then the minimum, it is the numpy dot mean of the list. Then now again, it means now I'll say print the range value, So let's run this. Already it will tell me that the value is 57. Why? Because it's 98 minus 48, which means the range is 50. So you see, this one it's used to calculate the minimum value in the list or in the data set. I'm saying it's used to calculate the max. This one is for a minimum. So it's used to calculate the maximum value in a data set. Then this one is used to calculate the minimum. So it's for a maximum value and the minimum. Then here the range we're just subtracting. So we've answered the question, the third question. Then the fourth question says, calculate the median of the data. Right, same applies. When we want to calculate the median of the data, so here it's calculate the median of the data. Remember, the median is the 50th percentile. It's actually in terms of its position, if we were to talk about the box and whisker plot, remember, let's say this is the minimum, this is the lower quartile, this is the median, this is the upper quartile, and this is the maximum. So we know that from the minimum, quartile 1 is 25% away from the minimum. Quartile 2 is 50% away from the minimum, and quartile 3 is 75% away from the minimum. So which means that if we were to actually calculate the median, we can calculate the median in two ways. We can calculate the median by using Numpy. So a median of the numbers. It will tell us that what is the median of this data. So you see, it says 78 is the median. By the way, I think we forgot to do something. Let's confirm something, because remember, we cannot calculate the median if we have not arranged the numbers from smallest to highest. Let me check something. Let's check if Python has arranged those numbers from smallest to highest. Let's do that. Let's say numbers, I'm arranging now, dot sort. So I'm sorting the numbers from smallest to highest. So this is the code where we can sort. We sort the numbers in a list in ascending order. In the ascending order. So let's print those numbers and check if we have arranged that. So I'll just say number. Let's print that. You see, now it is arranged from smallest to highest. Now let's confirm if it is indeed the same. Let's run this. It now says, oh, it means automatically when you are calculating the median, automatically Python has to arrange numbers from smallest to highest. You see that we got 78, which means it has already sorted the numbers from smallest to highest, even though we did not sort it, but still it will do that for us. And guys, another way of calculating the median, we can still calculate the median using something, the median using quartiles, using the quartile function. We can still calculate the median using the quartile, because remember, median it's quartile 2. So if I say mp.quartile, then I specify my values, the numbers. Then look at this, you must be careful here. What is the position of the quartile? Remember, quartile 1, it is actually it is 25% away from the minimum. If it's 25% away from the minimum, then this one is 50%, and this one is so it means if I specify the percentage, it will actually know that you are calculating the median. So if I put 0.5, it means it's the 50, it's a percentile in terms of its position. But if I put 0.25, it will actually calculate quartile 1. So let's run this. Let's do the running. It says Numpy has no attribute called quantile. Okay, it's quantile. Okay, quantile, not quartile. Okay, quantile. Let's do the running. Okay, maybe it's quantile. Okay, quantile. Yes, it's quantile, not quartile. So you see that we can still calculate the median using what you call a quantile. So it's specifying the values that you want to use and also the percentage. So which means if I put 0.25, I will now be calculating the lower quartile. It will not be the upper quartile. For example, look, if you recall very well from the lower grades, when we are calculating the median, we used to say we first calculate its position, and its position will be half of the n plus 1. And the half would be, how many numbers are here? Right, to avoid, okay, there are 15. So 15 plus 1, this gives us 16. And what is half of 16? It's 8, which means from here, the quartile 2 is we will get at position number 8. So it's 1, 2, 3, 4, 5, 6, 7, 8, which means this is the median. This is the median. If we wanted to calculate quartile 3, which will be the 75 percentile, you're going to add this. So this will be 3 over 4 by 16. And what is this? Obvious, it means this will give us 4. That will be 12. So which means it's 8, 9, 10, 11, 12. So which means quartile 3, it's 12. But what will be quartile 1? Quartile 1 is 25% away, which is 1/4 of the n plus 1, which is 1 over 4 of 16, which is just 4. So it means the value that is at 4, this one is the quartile 1. But I did not want to use this. I wanted us to use Python to compute everything there. Right, then the next one is the issue of, let's check the question. It says now calculate the interquartile range. Now we wanted to calculate the interquartile range. We now want to compute the IQR. Let's call this the IQR. We know that when we are calculating the IQR, the interquartile range mathematically, it's IQR, it is the upper quartile minus the lower quartile. So it's upper minus the lower. So which means to do that, we're going to do this. You can either say, let's now calculate the lower quartile underscore lower quartile, which is Q1. Should I call it Q1? It's fine. I can call it lower quartile or Q1. It's fine. Let's just call it Q1. And after that, we need Q3. Then after Q3, we want the IQR, which is Q3 minus Q1. Then we print the result. We print the IQR. By the way, let's do this. Let's say, based on what we got already, from what we got already, we need to confirm with what Python is going to give us. Quartile 3, it's how much? 88. And quartile, quartile 1, it's 63. So 88 minus 63, it gives us 25. So we need to confirm that again. So already to calculate the quartile 1, we're going to use this. But by the way, guys, you need to remember this. Quartile 1, its position, it's 25% away from the minimum, which means I have to put 0.25. Whereas quartile 3, it's 75% away from the minimum, which means from the minimum, we use 75%. So it means it will be 0.75, 0.25. Then let's now do the running. Let's run this. If we run this, indeed is giving us, okay, it's giving us how much here? It's giving us the 22.5. And what is the answer here? This was 20. How many numbers were here? Okay, let me check something here. The quantile of the 0.25 and the 0.75. Okay, let's do the print out of this. I wanted to check them. Let's do the print out of these things. Okay, I wanted to check them. What is Q1? Q1, let's run this. It says 63.5. Oh, okay. No, I think I understand what it has done. But why is it says, okay, let's say Q, how many numbers are here? 15 plus 1. It means this one is actually estimating using, it does not add by 1. Because if it's, for example, if it's half of, it uses, in other ways, it's using, let me do this. It actually says Q1 position it's 1/4 of 15, and which gives us 15 divided by 4, which is 3.75. So it's number 3. Number 3 is 1, 2, 3, which is 55 plus 0.75 of 63 minus 55. But now this is 55 plus 0.75 into 63 minus 55, then which is how much? But it says 63, so it's 3.1234. Oh, no, sorry, it's 1, 2, 3. So it takes number 3 and 0.7, so it's 63. 63 minus 55 times 0.75 plus 55, which gives us 61. Let me check what it has actually computed. This. Okay, let's check quartile 3. What will be quartile 3? It says 86. Okay, quantiles. Okay, let me check something. Just a minute, guys. I just want to check something. Files, Python. Okay. Okay. Quantiles values 0.75. Okay. And what is the issue? Okay, fine. Let's try this. Let's say I'm using, let's say in the context of stats st. Let me check something. It says statistics has no. Okay, fine. Let me just call it Numpy NP. Okay, then it says quantile number 0.25. 0.25. Okay, let me just do this. Say 25. I want to check something. Okay, so it means 0.25 and 0.75. Okay, let's say 0.3. I want to see something, and 0.8. Do the running. So Q3. Oh, it's 8. So it means it's calculating this when it is rounded to the nearest. Okay, when it's rounded to the nearest. So it means it when we use 0.25 and 0.75 is just estimating. So which means here when we use exactly 0.3 and 0.8 to the nearest, then is actually giving us 23.5, so which is roughly 24, but yeah, there we got 25. Let me check quartile 1. Let's say with 0.3 and 0.8. Let's check quartile 1. Quartile 1, it says 64 instead of 63. So you see that is just estimating 0.2. Let's use 0.2. It says 61.25. It says 63.5. Okay, 0.24. 63.3 something, then 0.23, 63 point, so 0.22, 63.0. So you see that it's actually doing an approximation. It's fine. It's fine. Let's just use 0.25 and 0.75 because it shows that it's only approximating. It's fine. So let's use 0.25 and 0.75. So this is an approximation of the interquartile range. Then again, we can move on and check on like how to actually calculate the standard deviation. Obvious, in grade 12, there are two formulas of calculating the standard deviation. We have what you call a population standard deviation and a sample standard deviation. According to the formula, it says this symbol is for a population, which is the square root of the sum of the deviation from the mean divided by n. If you're using n, then this is called a population standard deviation. But when we use n minus 1, it becomes a sample. That's why on most of the financial calculators, you find that we have these two. But this one is called a population standard deviation, then this one is the sample. Right, let's now do the calculation. Obvious, we can calculate the standard deviation of this by using what is called the Numpy, numpy.std. This is the function for calculating the standard deviation. So if we do this, ladies and gentlemen, we put the numbers, then it will tell us that the standard deviation for this is 16.3, and we can also round this number. Also, the function of round is also a numpy function, so we can round to, let's say, to 2 decimal places, to 2 decimal places, or even 3 decimal places, you see. But let's just put 2 decimal places. But in Python here, it's not putting 0, it's just say 13.3. So this is the answer. This is the standard deviation of this data. But according to this, it's actually using the population standard deviation. It's using the population standard deviation. So that is what you need to know. Then again, ladies and gentlemen, it depends with what you want to get. For example, if we do not want a standard deviation for a population, maybe we do not want this one for sigma x. But the sigma x is the one which is 16.3. But if you want this, it will be different. Why? Because with this, it's when we are calculator, it says the sum of the observation from the mean deviation divided by n minus 1. We do not divide by n, we divide by n minus 1, which means here the degree of freedom, it's now n minus 1. So it means automatically Python already know that when we want, if you are just doing this, it assumes that the degree of freedom here, it's 0. But if we put the degree of freedom to be 1, look what is going to happen. It means inside this function, if I say, inside the function here, if I say the DDOF, which means the degree of freedom, now it's 1, which means 1 means n minus 1. Then now let's do the run. You see it's giving us 16.87. And even if you use your financial calculator, you put that, you'll see that when you use your calculator, the sample standard deviation is the one which will be 16.87. 16.87. So that will be the sample. But however, here, if you do not put this, it means it knows that you are actually calculating the population standard deviation. So it's very, very, very important. And again, ladies and gentlemen, we can still do the comment by looking on the mean and the median. By the way, what is the mean of the data? The mean of the data was 16 point, I'm saying 73.6. And what is the median? The median is 78. The mean is 73.6 and the median is 78. Let's analyze this. Let's analyze this. Let me try to erase this. So, which means that if we compare this, we can also do the comment in terms of the distribution without having to draw a box and whisker plot. We can easily see that this distribution, when we compare the mean and the median, let's look at this. Let's look at the mean and let's look at the median. Okay, the mean and the median. Okay, the mean is 73.6 and the median is 78. So you can easily see that the mean is less than the median. And when the mean is below the median, it shows that we have skewed to the left distribution, skewed to the left or negatively skewed distribution. It is negatively skewed. What does it mean? It means when you draw the box and whisker plot, more space on the box will be on the left. So more space will be on the left, because look at this. This is the median, but the average is somewhere here. You see that the mean is below the median. That's why we have skewed to the left distribution. But we can still attest this by drawing a box and whisker plot. And to do that, ladies and gentlemen, I'm going to import a function called Matplot, which we're going to talk about that in the next video. So I'm going to import, let's import the Matplot library for visualization, We use this together with something called the Seaborn. I think the Seaborn, but now I'm adding this just to plot the box and whisker plot of this data. So let's do that. We're going to say import Matplot library. Let's call it .pyplot. I'll talk about this in the next video, pyplot. So let's set as an alias as PLT. So it means wherever we see a PLT, we know we're talking about. So I'm going to do this. Let's say we're going to say, okay, fine. PLT.boxplot. I need to do a box plot of what? Of the numbers. I need to construct a box plot of the numbers. And let me give a title, title of this. So I'm going to say, this is a box plot for the number of liters. The number of liters of diesel purchased. Then I can also say plt.show, but there's no need. I just wanted to show my box plot. Let's do the plt.show, because already you see it's showing this, but look at the box and whisker plot. It's now in a vertical format. It's now in a vertical format. And what if I don't want it to be, I don't want this box plot to be vertically. I want this box plot to be horizontally, which means I can go inside this. Remember, you can still go to your Google and say, okay, fine. Okay. If you just say, apologize. If you just say plt.boxplot, you see .boxplot syntax. So, okay, we'll just go through the Matplot because I'm talking about it. Let's just try to open that. You see, it shows the syntax to say when you are constructing your box plot, always you need to consider this. Inside this, you must have your data, your notch, symmetrical, vertical. You see vertical, it says 9. Do you want the graph to be vertical or do you want it to be horizontal? Do you want to show the whiskers, the positions, the width? These are some of the things which are not that important, but if you want to understand more, you can go through that. So which means here we can use that function called vertical to say vertical equals to false. When I say false, it means I'm saying I don't want this box plot to be vertical. I want it to be horizontal, because if I say it true, it means it will be vertical. So it means if I do this and do the running, you see now it is horizontally. Then by looking at this, let's say, for example, I wanted to increase the size. Can you still say plt.figure? Figure inside this, we're going to say fig size in as a tuple. Then fig size, let's say I want it to be bigger, so it will be 10 and 20, but it will be bigger. Let's say 10 and 8. 10 and 8. So I wanted to increase the size of this box plot. So you see, I've now increased the size of the box plot. So you can easily see that. Let's say I wanted to reduce it. Let me just make, so it means this is the height and this is the width. So it means, let me reduce the height. Let me make the height to be 5 and do the running. Let's run. You see, it's now, okay, it's now increasing the okay, let's say 8 and 5 this side and run it. Right. So you can easily see that this is, so what if I wanted to change the color? Let's check if there's any show interval, ticket labels, box, the Z order, data. Let's check. There's no part for the color. The mean line, the show means functions, they are there. Okay, fine. Then now this is the, I think there's no part for changing the color. Right, but for now it's fine. Let's just go through what we have done. So you can easily look, when you see from this box and whisker diagram, you can see that this is the minimum and this is the quartile 1, this is quartile 2, I'm sorry, quartile 2 here, this is quartile 3, and this is the maximum. And you can see that this is the left part and this is the right. So you see more spaces on the left because the mean is somewhere here, which means this is skewed. It is skewed to the left. So we have skewed to the left or negatively skewed distribution. So we have skewed to the left or negatively skewed distribution with no outliers. You can see that there are no outliers. But if you can do this, let's say in my data, I'm going to put a number here. Let me say the number here, it's okay. Let's say the number here, it's in the list. I'm adding another number here. Okay, so I apologize. Let's add a number here. Where is it? Here. Let's say the number here, it's 200. And try to run this. Let's go to the box and whisker plot. Let's go. We can identify an outlier. You see, it shows that, you see now the data is still skewed to the left, but however, this time around, we have an outlier. There is an outlier or an extreme value, which is far much away from others. And that extreme value, you can easily see it here. It's there. It's called an outlier. Outlier is there. So this is our outlier. This is an example of an outlier, the extreme value, which is far much away from others, even from the maximum. You see, this is now regarded as an outlier. But if we do away with that value in the data set, then we're no longer gonna have any outlier. So the outlier will not be there. So let's run this and we come back and we run this again. So this is now an outlier. So we no longer have an outlier, ladies and gentlemen. And remember, it's not about drawing a box plot. We can even construct a histogram if we wanted to do that. We can construct a histogram, and to do that, we're gonna say hist plot instead of, so it's gonna be hist plot. But this time around, I will not, because this does not have a vertical power function. And this will be a histogram or a hist plot. Let's say histogram, or a hist plot for the number. So let's do the running. So, okay, it says hist plot has no, matplot has no something. So it means it's the histogram. I think, okay, let's use the histogram and check if that it says it has no. Okay, let me do this. Let's check it well. Hist plt dot hist hist in Python. I think it should be hist. Okay, so let's check. Oh, it's plt dot hist, not histogram. So it means the hist plot is for a seaborn. Okay, np.histogram. Okay, fine. So it's plt.hist. plt.hist. Okay, so let's do that. So it's gonna be plt.hist, the number hist. Then let's do the running. So you see now it's giving us the data. This is the data, the histogram for this data. And within this, if we construct what is called the KDE, let's check if the KDE is there. KDE equals to true, but I think this applies to the seaborn one. Okay, let's try to run this. So with the KDE, I want that histogram to have the line constructed on it. But when we check on the function, we have that part of KDE. Density, okay, it's not the bins. Hist align, horizontally color. Color is there, stacked data. So it means the KD is not there. Here is talking about the bins. The bins. Okay, it means the KDE would be under that low. So it means you have to say density. So it will be the component. So it will say error, yes. So let's say density instead of KDE. Density equals to true. Let's run that and check what is going to show. Okay, it's still showing the same things. Okay, so what I wanted to, what I was actually explaining the KDE, I wanted it to just draw to show the lines here, to just show the lines here to say. So you see that within this, it's actually shown that it is more tail on the left. So that's why we said it is skewed to the left. It is skewed to the left. Then, but how about if I wanted to draw just a bar plot? So if we wanted to draw a bar plot, I think we're gonna do the same, but this time around to be, okay, let me say plt.plot. Then inside will be the kind. What do I want? The kind. Then this will be a bar plot. Then I can also put the title inside to say, this is the bar plot for the number of liters purchased of petrol, but it's fine. Number of liters purchased. Then there's no need for a title. Okay, so it says, oh, okay, I do not put the data. Okay, let me just say, is it? Oh, okay, the data. Okay, numbers plot. Okay, it says list as no. Oh, it's because we're using a list, so it means it will not. Okay, let me just try to do this. plt.plot kind. Let's say data is equals to numbers. I want to see something here. Let's run and check. Or it's just displaying them without. Okay, fine. So let's just leave it then. So yeah, actually the main aim was not to visualize this here. I was just commenting on the distribution. So actually the main aim was to talk about the Numpy and the Pandas, and also the list comprehension. So this is what we're actually focusing on. I think you enjoyed the section, ladies and gentlemen. Don't forget to like, subscribe, and hit the bell button for future videos notifications.